Hi Advanced Lab, this is Mulhall and Majid. We're going to talk to you now very quickly about the basic setup for the diode laser spectroscopy. So this is a tremendously exciting experiment and I hope everybody gets a chance to do it. I'm going to go through the components first. This is a controller and it controls this guy here. This is a diode laser inside here. This is a very special diode laser. There's two things about it that are interesting. One of them is it's infrared and the other one is you can tune it. So we have a wavelength knob. We can change the wavelength that this thing raises at. There's two ways that we change the wavelength. In diode lasers, the wavelength depends on a band gap of it's a semiconductor. So the current through the semiconductor changes the charge carrier concentration. That can change the energy gap and that can change the wavelength. So what we can do is we can change the current going through the laser. That'll do two things. It'll make it a little bit brighter and it'll also make the wavelength a little bit different. The second thing we can do is this has a diffraction grating. We can use feedback, and we can send some of the laser back into itself. That also changes the wavelength a little bit. You'll have to. This is a little bit complicated, and you're going to have to read about it in the first chapter of the manual. But ultimately, this is the controller, this is the laser, and we're doing two things. We're tilting a diffraction grating with a piezo stack, and we're also changing a current. Well, we have a ramp generator. So if you see here, there's a ramp generator. This ramp generator just gives us an up, down ramp. And what this will do is we can send some of this ramp to control the current, some of it to control the piezoelectric. I'm going to, if you listen carefully, listen. Hear that chirping? That's because we're sending a ramp signal into some piezo stacks here and they're acting like a loudspeaker. Okay, this is an infrared laser, so you can't really see it. So we have to use this little camera here. We have the laser coming straight through here. This is a beam splitter, we'll get into that in a second. This is a rubidium gas cell, and there's a card here. We can see a spot. We can see a spot on the card right there. Now, right now this is just a diode. If I turn up the current, and I turn it up, turn it up, turn it up, now it's lasing. See, it's just a diode, now it's a laser. So there's a transition where it happens. We can monitor the current with a digital multimeter. 3.7 volts means 37 milliamps are going through the laser. Okay, so well, this is really not how we're going to use it. We're going to, we have a, oh, I'm using the camera. We can actually see this because we can use this detector here to monitor the, we shine the laser through a rubidium gas cell and see what goes into the detector. We can also, we have a beam splitter here, we can also see, we can compare it with the laser that doesn't go through the gas and we can see what the two signals look like. Okay, this is the signal that goes through the gas. This yellow line here is a signal that goes through the gas cell. And as we turn it up, ooh, we see what happened. There was some absorption that happened. This is essentially our signal. We can subtract, if we look here, this is the signal that's unabsorbed. So this is the one that goes through, that doesn't go through the rubidium, and the yellow one is the one that does go through the rubidium. We can actually just put these two guys into a comparator, compare them, and then see what comes out. We should just see the difference between them, and that'll be the most useful. We can kill channel 2. See, look, I can subtract one relative to the other. There's all the unabsorbed, all the absorbed, and if I just get them right, I can subtract them like that. Excellent. So this is essentially what we're after here. This is our signal. When you read through the stuff, you'll see that we have 4. When you read through the stuff, you'll see that we have 4 absorption lines. And there they are. This is our data. It's absolutely beautiful. Now I'm going to show you something. When the light goes in, it's been absorbed here. So as you go along on the oscilloscope, because you're changing intensity because you're changing current. When you change the current, you change the wavelength. So the horizontal axis on the oscilloscope is usually a wavelength axis. So at certain wavelengths, we get absorption. This is a lot to take in now, but when you read the manual, hopefully all this will become clear. This is just really the purpose of this video is just to show you how it can be set up. But look at this. if light goes in and it gets absorbed, well, it doesn't stay inside rubidium atoms. Rubidium atoms re-emit. So let's see what's happening inside the cell. And look, inside the cell, we can see this line here. That's the rubidium gas re-emitting the absorbed photons. It's very pretty. Let's turn down the frequency. See? Now let's look at let's look back here at let's put this guy here, like this, and then we can turn beautiful. Now what do you see? You see every time she goes up, we get a flash. It's very nice. Yeah. So we're scanning through the wavelengths and we get a flash. Okay, let's come over here. That's just for fun. This is really not that. Notice I'm wearing goggles. You have to wear goggles. This is a very powerful laser. It would hurt your eyes if you look directly into it. It won't hurt your eyes without careful planning. It won't hurt your eyes by being reflected off something, but it would if you look directly into it. So obviously don't look directly into it. Now, this is the diode laser head. When you have everything set up nicely, you should cover it. You're going to have to align it. You're going to have to take care of everything yourself. This is a neutral beam filter, a neutral density filter. This just cuts off the intensity. This is a beam splitter. There's detectors. This is handy. This is just a little card so that you can monitor whereabouts is the beam. You see, we can see the beam right there, and you use the camera to find out where the beam is. Looking at the... Okay, so all this is going to be dismantled and left. All the pieces you need are going to be lined up on the optics table over there. That's how you're going to perform the experiment. So it could take you the first whole lab session to actually get up to speed, get this far up. Okay? Cool. That's it.